Hello guys, in this video we are going to discuss the last topics for differentiability. Okay, so tapos na tayo dito sa definition of derivative, differentiability. So in this video we are going to discuss about these two subtopics. Okay, so ayan, reasons for non-differentiability, diba? Isa sa mga definition ng differentiability is there is a finite slope of tangent. Okay, slope of a tangent line through a certain point. Okay, kapag may ganun, ibig sabihin differentiable siya dun sa point na yun. Okay, so a function has a derivative at a point x equals a if the slopes of the second lines through the point P and a nearby point Q on the graph approach a limit. So meron siyang finite, okay, limit as Q approaches P. However, a function will fail to have a derivative at a point where the graph has first a corner where the one-sided derivatives differ, second an oscillation point where the one-sided derivatives does not or do not exist, 3. A vertical tangent where the absolute value of the slope PQ approaches infinity, and 4. A discontinuity. Such slopeless points may be roughly classified as sharp points, oscillation points, steep points, and point of discontinuity. So ayan, ito yung case 1. Pag may sharp point na ganyan or sharp corner, automatic po, kahit continuous yung function, okay, ang left hand at saka right hand derivative niya is not equal. Okay, kasi yung slope is not going to be equal. Okay, ganyan yung magiging itsura niya. Next is an oscillation point. Okay, katulad ng curve na to. Automatic po, okay, yung tangent niya, tangent line is yung right hand and the left hand is not equal. Okay, if in a continuous function f, either the left hand derivative or right hand derivative does not exist at x equals to a. Okay, because of too much oscillation of the graph in the neighborhood of the point, then such a point is called an oscillation point. Okay, ito is an example of non-differentiable at a certain point. Next, vertical tangent, non-differentiable. Although continuous yung function, not differentiable pa rin siya kasi ang tangent point or ang tangent line is a vertical line. Okay? Next, discontinuity. Automatic po pag discontinuous ang function, automatic po na non-differentiable siya at that point of discontinuity. Okay? So, ganyan po siya. So, relation between continuity and differentiability. Ano ba ang relationship ng continuity or continuous function sa differentiability? If a function f is differentiable at x equals to a, then it must be a continuous function. Okay, kapag differentiable siya at x equals to a, automatic po, continuous siya sa point x equals to a na yun. Okay, since f is differentiable at x equals to a, the limit of the derivative exists. Okay, so example, given f of x is equals to x squared, examine the continuity and derivability at x equals to 0. Okay, so solve natin. F prime x is equals to the limit of x plus delta x squared minus x squared all over delta x when delta x approaches 0. Okay, so let's simplify. X squared plus 2x delta x plus delta x squared minus x squared delta x. So, magka-cancel to. Sulat lang natin saglit. Okay, then magka-cancel si delta x. Okay, ang matitira dito is 2x plus delta x. siya at x equals to 0. So, 2 times 0 is equals to 0. Okay? Ito is at right hand. Okay, this is at right hand. Okay, try natin yung left hand derivative. Okay, pag left hand derivative, automatic we are going to use here is negative x squared. Okay, so kasi ganito yan, ano, function of x is equals to x squared kapag x is greater than 0, kasi po pag greater than 0 automatic positive to, 0 if x equals to 0, negative x squared if x is less than 0. So gamitin natin ito sa left hand derivative. Okay, so negative x minus delta x squared minus x squared. Okay, minus x squared. Okay, divided by delta x. Okay, so negative x squared minus 2x delta x plus delta x squared positive x squared. Okay, so over delta x, so negative x squared plus 2x delta x minus delta x squared plus x squared all over delta x. So magka-cancel to. Ang matitira dito is 2x minus delta x. Okay, limit delta x when delta x approaches 0 from the left. Okay, so 0 ulit to. 2x pa din ang sagot. So 2 times 0 is equals to 0. So therefore, left hand derivative and right hand derivative is equal. So we can conclude that the function of x squared is differentiable at x is equals to 0, and of course it is continuous. Okay, at x equals to 0. Okay, automatic pag differentiable siya, continuous siya at that point then. Next, comment on the differentiability of, okay, pag left hand, okay, sa left hand derivative tayo, so f prime x limit delta x approaches 0 from the left. Okay, ang gamitin natin ito, x plus delta x. Ay, left ito, so minus ito. Minus x all over delta x. So this one would be, magka-cancel to. Negative ito, so this is equivalent to 1. Okay? Tama ba yung sagot natin kanina? Left hand, so negative pala ito. Okay? So kung negative yan, pagiging negative 2x to plus, o ganun pa din, 0 pa din. Okay? So ito naman, negative cancel negative delta x over delta x, negative delta x is equals to 1. Okay, so yung left hand limit is equals to 1. Try natin sa right hand, f prime x limit delta x 0 positive, so this is x plus delta x plus 2. Ito yung gamitin natin, minus x plus 2 all over delta x. Okay, so ang mangyari dyan is magka-cancel to, delta x over delta x is equals to 1. So therefore, ang left hand at saka right hand limit each other. So we can conclude that the function of x is differentiable at x equals to 1, and of course it is continuous, okay, at x equals to 1 din. Okay, ayan. So differentiable na siya, continuous pa siya. Okay, so ano po ang conclusion natin dito? Ito yung relationship ng differentiable at continuous. Kapag differentiable ang isang limit or function, automatic po continuous siya at that certain point. Okay, kung differentiable siya at x equals to a, automatic continuous siya. Okay, pag continuous siya, ang function ay continuous at x equals to a, it is not always na differentiable. Kasi nga, diba, sa example natin kanina, continuous ito, pero hindi siya differentiable kasi ang tangent line is a vertical line. Continuous ito but not differentiable kasi oscillation. Continuous ito but not differentiable kasi may corner. So, ang left hand at saka right hand is not equal. Okay? So, kaya yun po ang findings natin na kapag continuous, it is not always differentiable. Pag discontinuous, automatic po na differentiable. Kasi, one of the reason why hindi differentiable ang isang function dahil discontinuity, okay, at a certain point. Okay? So, ibig sabihin, pag discontinuous siya at x equals to a, non-differentiable siya kagad. Both one-sided derivative exist, continuous siya kagad. Okay? Both one-sided derivative exists, it is continuous. Non-differentiable, okay, is not always discontinuous. Ibig sabihin, hindi porket hindi siya differentiable at a certain point, is discontinuous na siya. Okay? So, ito po yung mga dapat natin tandaan na relationship ng differentiable. Okay?